So worksheet 3, number 10. I can tell it's an ellipse because both of the squared terms are positive and they have different coefficients. So that's an ellipse. Let's group the pieces together so that we can complete the square. And then I'll get the 16 out of the way to the other side. And then half it, square it, add it. Half it, square it, add it, HSA. Don't forget to do all three of those steps. So B over 2 is 4. Square it, 16. Add it to both sides. Oh, the y stuff's a little bit messed up because of that. That y squared has a 9 on it. So let's factor out the 9. Because I can't half it, square it, add it until the y squared is 1. So B over 2 is negative 1. I square that, I get 9. Or no, I square that, I get 1. Jumping ahead. But because of that 9 out front, I'm going to add 9 to both sides. So I am running out of space here, but x plus 4 squared plus 9 times y minus 1 squared equals 9. Let's divide everybody by 9 to make it equal to 1. So my final equation is x plus 4 squared over 9 plus y minus 1 squared over 1 equals 1. And I guess you don't have to put over 1, but to make it match what a ellipse should look like, I would put over 1. That way it sort of fits the format of the rest of the problem. Center is at negative 4, 1. If it's under x, go that many in x. Remember, that's true for ellipses or hyperbolas. So we'll go left and right 3 from the center. And then we'll go up and down 1, because 1 is under y. And so now I can list those vertices. Negative 1, 1. Negative 7, 1. Negative 4, 2, and negative 4, 0. Ellipses have 4 vertices. Make sure you list them all. Hyperbolas have 2 vertices, but you can list all 4 if you want to. The name of the other vertices are called co-vertices. So they're like sort of vertices, but sort of not. So you graph them. They help you draw the box, and then the asymptotes, if they're not really vertices. So list them or not, your choice on the hyperbolas. Anyway, back to this ellipse. I can sketch in the ellipse now. That's not the greatest ellipse in the world, but that's okay. Again, as long as you're not just playing connect the dots, you'll be okay on that. Foci are C away from the center, and C squared equals A squared. Let's see, for an ellipse, it's minus, because it's always opposite of whatever the main sign is. All right, so for an ellipse, it's a squared minus b squared. For a hyperbola, it'd be plus b squared. So 9 minus 1 is 8. So c is the square root of 8. Be careful, that the foci aren't the square root of 8. The foci are square root of 8 away from the center. So square root of 8. Left and right, because it's always on the main axis. All right, technical difficulties here. All right, so I'm going to go square root of 8 away from the center. So my center is at negative 4, 1. Which way am I going to go to get to my foci? Left and right or up and down? Left and right, because that'll be on the main axis. So which coordinate should I adjust? The first coordinate or the second coordinate? The x or the y? The x, because that's what controls left and right. So I started at negative 4, 1, but I want to change my x-coordinate by plus and minus the square root of 8. That would move me right and left square root of 8. You don't have to graph the foci, because usually they're weird square roots, but it might help you visualize where they are and help you write the points if you want to. Eccentricity is C over A. This is kind of the only spot where you got to know which one's A and which one's B. C is square root of 8. A is always the bigger one for an ellipse. So A is 3. So square root of 8 over 3 is the eccentricity.